Hey guys, we are in Chapter 3 Geometry and we're going to be talking about parallel lines and transversals. Our vocabulary is a bit extensive, but we have some concepts that you should be pretty much familiar with. So the first one we'll talk about is parallel lines. So parallel lines are two or more lines in the same plane. This part is really important. Two or more lines in the same plane that do not intersect. And you've seen this all your life or mathematical life. You may see two lines that are like this going in the same direction. But the key to this is that they're in the same plane. And the reason why I make that distinction is because skewed lines also are two or more lines. I'm going to just talk about two for the moment that are that do not intersect, except they're not in the same plane. So I talk about skew lines as two lines that are not in the same plane, and the hint here is that they don't intersect. So if you've got two lines that intersect, there is a plane, namely the plane that I've drawn this on, that these two lines intersect in. And anytime you have, if you can imagine two lines that intersect, they have to share a plane. They have to be in the same plane. So skewed lines are lines that are not in the same plane at all. And I think I have a little image here that might be helpful. So here, this would be an example of skewed lines, and this picture is taken directly from your textbook. Another way of thinking about skewed lines, sorry about that, another way of thinking about skewed lines would be to think about like a cube and consider that its edges represents lines. So this is a line, let's call this line L, and let's call this line, let's say M. Notice that these two lines are never going to touch each other, if you can kind of see the three-dimensionality of this picture. So these would be skewed lines. Let's check out this next vocabulary word, transversal. Well, before we check out transversal, what we probably should do is check out parallel planes. And the idea of parallel planes really goes back to, I guess, this cube picture, two planes that will not intersect, right? So if we think about two faces of this cube, let's say this face over here that I will color in green, and let's say this face over here, let me get the dotted line to represent the face opposite it, right? And this would be dotted as well. And this face over here, which I have in orange, kind of a solid color there. These two faces are parallel planes because they extend in infinitely in every direction, and they will never touch each other. So that's what a parallel plane is. So now let's get to the word transversal. Transversal is really just a line that cuts two other lines, all right? So I might have this line here and this line going this way, and my transversal would be this line here. Let me make that prettier for you. This transversal would be this line here, okay? And I'll call that transversal T. And so a transversal is any line that intersects two or more other lines, and that's pretty straightforward. So this picture of a transversal and the line is going to get a lot of play in the next couple of sections that we're going to work on. So I'm actually going to capture it and make it a little bit larger so I can talk about some of the things that's going on here. So if you are writing notes and writing definitions are kind of hard or they don't really stick with you, this might be a thing that does. So one of the things I want you to do if you're doing this is to make sure and number each of these angles here, because this is going to be important. So I'm going to call this angle 1, 2, 3, 4, 5, 6, and 7 and 8. And the reason why I want us to number it the same way is because it'll help us when we are describing or naming these angles, because these angles have specific names that should be remembered. All right, so here we got line T, and it's a transversal, and it's crossing these other two lines, and it's creating these angles. So there are angles that are called interior angles. Interior angles are going to be these angles that I highlight in yellow. So the interior angles are all the ones that are literally inside of the two lines. These guys are interior angles. And I guess reflexively, exterior angles, I'll highlight them in green, are going to be angles on the outside of the two lines. Notice that all of the angles I'm talking about will be somehow rubbing up or attached to or created by the transversal. So the interior angles are these yellow ones inside, and the exterior angles are these guys on the outside that are in green. Consecutive interior angles. Those angles are obviously interior, and consecutive means they are on the same side as the transversal. In this case, it means anyway, and they come one after another, okay? So the consecutive interior angles here would be angle 3 and angle 5. And then another pair of consecutive interior angles would be angle 4 and angle 6. The next type of angles we need to identify and locate are alternate interior angles. And so alternate interior angles are going to be interior, as we talked about before, but on alternate sides of the transversal. So this angle is an alternate interior angle to this angle, right? So those guys are going to be alternate interior angles. And then similarly, you'll see that this angle is an alternate interior angle to that angle, okay? So when I talk about alternate interior angle pairs, in this case, I would tell you that angle 5 and angle 4 are alternate interior angles, and then angle 3 and angle 6 are another pair of alternate interior angles. Alternate exterior angles, I'm sure you're kind of you got an idea of where we're going with that part. They're on alternate sides of the transversal, and they are exterior. So we've got 2 and 7 are alternate exterior angles, and 1 and 8 are alternate exterior angles. All right, so then the final thing we got is corresponding angles. And when I think about corresponding angles, I like to highlight this cross here, the cross between the crosses that are made by the transversal and the 2 lines that the transversal intersects. And I want you to think about the crosses and think about the location of each angle in reference to the cross. Corresponding angles are located in the same place. So angle 2 here corresponds with angle 6 here. Angle 8 here corresponds with angle 4 here. Angle 3 corresponds with angle 7, and I think you guessed it, angle 5 corresponds with angle 1. So I will write those pairings down, and we will be done our vocabulary. So just to reiterate, our corresponding angles are angles 1 and 5, and then the corresponding pair would be 2 and 6, then 3 and 7, and another pair would be 4 and 8. Corresponding angles are angles that are located at the same place, at the corresponding place in reference to the intersection of the transversal with the 2 lines. Whew, that was a lot of vocabulary. So let's get started with a couple of, and I think we've already done this. Let's get started with a couple of questions. So here we are looking at, yes, we're looking at a piece of cheese, and it's a piece of cheese cut in this kind of a shape that looks kind of like a pyramid or half of a cube, and we're going to identify each of the following using the wedge of cheese below. All segments that are parallel to JP. So sometimes it's really helpful to have these pictures and highlight what you're looking for. So I'm looking at JP. Where are you, JP? So here's JP, and I want all angles that are parallel to segments that are parallel to JP. And we see we've got KQ here and LR. Those are the only 2. Next, we want a segment, just one, a segment that is skewed to KL. So I identify KL over here, and maybe I might darken that red line. There's KL, and I want something that is skew. Skew, we remember, doesn't exist in the same plane. So these guys won't help, and this guy won't help because these are all in the same plane. But maybe PR works, or even PQ could work. I'm going to go for PR just because it's easier for me to highlight, and I'll write that down here. Then finally, part C, we're asked to find a plane that is parallel to the plane PQR, and the only other plane that we can refer to would be the plane at the top, which is plane JKL. And that's it for example 1. In example 2, we're asked to classify each angle pair based on the information that we talked about before. Remember, these 2 lines are cut by another line, so this is 2 lines cut by a transversal. So we've got interior, exterior, and so we're going to classify these pairs of lines, these pairs of angles rather, pardon me, by these words here. So if I look at angle 1 and angle 5, I see that they're on the outside and they're on alternate sides of the transversal. These are obviously alternate exterior angles. I'll abbreviate it like this: alternate exterior angles. And then angle 6 and angle 7. Let's take a look at those two. Angle 6 and angle 7 are obviously inside. They're inside and they're on the same side of the transversal, so they're obviously consecutive interior angles. And now that we've dealt with 7 and 6, let's take a look at 2 and 4. So angles 2 and angle 4, this reminds me of, remember we had the crosses and we said, oh, when you're at the same place you are corresponding angles. That's what we have. We've got corresponding angles here, and I'd abbreviate it like that. And finally, angle 2 and angle 6, let's take a look at that. This guy here and this guy here. Angles 2 and angle 6 are interior, but they're on opposite sides or alternate sides. These are alternate interior angles. So in this exercise, we're going to do two things. We're going to identify, using this picture, we're going to identify the transversal. Remember, that's the line that's cutting two other lines. And then we're going to classify, based on that, we're going to classify these angles. So over here, let's look at angle 1 and 3, I think we've got. So angle 1 is here. Let me make this a little bit larger. Angle 1 and angle 3. Remember that the transversal always has to touch the two angles that you're talking about. So I'm going to draw this line. This is clearly my transversal. So H is my transversal. And if I'm looking at H, angle 1 and angle 3 are alternate exterior angles. I hope you can see that. They're on alternate sides of the transversal and they're outside of the two lines that the transversal cuts. Let's look at this next guy. So we've got angle 5 and angle 6. And again, remember that the transversal must touch both of those angles. So in this case, the transversal is this guy over here. So my transversal is K. And notice that they're both on the same side, but they're interior. It looks like they are consecutive interior angles. Just an aside, in some textbooks they're called same side interior angles, which might be a little bit clearer, but in this text they're called consecutive interior angles. And finally, let's take a look at this one where we're looking at angle 2 and angle 6. Angle 2 and angle 6, you see them in blue here. Angle 2 and angle 6 are created by, both of them need this line to create those angles, and therefore the transversal is line L. And the relationship here is that these two angles are, they're in similar placement, given the transversal cutting these two lines. These two angles are called corresponding angles. And that really is it. This chapter, this section rather, is a lot about vocabulary. It really is just getting used to, I didn't show you this one, but this is in your text, the location of these different types of angles. It's going to be really important, especially for the next chapter, the next section. So make sure you memorize those. Go over the video if you need to. Go over the little bits of information, these keys that are in the textbook. It might be helpful, and make sure you have it down because that's going to be really helpful in the next section. Talk to you guys later. Take care. Bye-bye.